All right, this is going to be my third attempt at making this video just because the last couple were too long. So if you feel like I'm speeding through this, just pause it and catch up. Okay, so special right triangles, lesson 7.3. The first thing that I want you to know is a 45, 45, 90. Very unique. Remember that the sides, the two legs, are congruent if it's a 45, 45. We know that about from isosceles triangles. And that the hypotenuse is always the square root of 2 times the short side, or the short leg. I remember this because this triangle has two congruent sides, and that reminds me that the hypotenuse is the square root of 2. Okay, that's how I remember that. Okay, so let's look at example 1. It says find A. So remember, this is a 45, 45, so I know these legs are congruent to each other. I also know that the hypotenuse, which is 8, equals the short leg times the square root of 2. Okay? Now, the problem is that I'm trying to find A. I need to get it all by itself. So the first thing I need to do is divide both sides by the square root of 2. However, we never, ever leave rational numbers in the denominator. So I need to rationalize the denominator. Those cancel out, and here I'm going to multiply both top and bottom by square root of 2 over 2. Now remember, the square root of 2 times the square root of 2 equals 2. So I have 8 root 2 over 2 equals A. And then I can actually reduce that. I'm able to reduce 8 divided by 2. So that is actually going to equal 4 root 2. So A equals 4 root 2. Okay. Example 2, I have a triangle, or sorry, I have a square. I know this because all 4 sides are congruent, and I have a right angle. I'm just going to focus on this piece right here, okay? So if I have a 90 degree with 2 sides congruent, then I know that these are 45s. All right, so that's the first answer. What is the value of x? Well, x equals, excuse me, x equals 45 degrees. All right, now I need to find y. I know that this leg, the short leg, is 9.6, and I know that my hypotenuse is always my short leg times the square root of 2, so y equals my short leg times the square root of 2. So those are my two answers. X equals 45 and y equals 9.6 times the square root of 2. Okay. Now on a 30, 60, 90 triangle, if you notice that, the short leg, we always start with the short leg is n, and then the longest side, or the hypotenuse, is twice that, or 2n. So it says the hypotenuse is twice the short leg. So the hypotenuse is 2n. And then the long leg is the short leg times the square root of 3. This is how I remember that. I know that this triangle has 3 different measures, and I'm talking about the leg lengths, the sides. And I know that the hypotenuse equals twice the short side, and then the longest leg equals the short side times root 3. And I remember this because, again, there are 3 different sides. Okay, so hopefully that'll help you. So let's look at example 3. It asks us to find QR. So I have a 30, 60, 90 triangle. My short leg, I'll just use n for reference purposes, is 4 root 3 over 3. So we're going to find QR, and we're also going to find PR, even though it doesn't ask for that. Okay? So QR is my hypotenuse, and so I know that that's going to be the short leg times 2. So 4 root 3 over 3. Remember 2 is the same thing as 2 over 1. Multiply fractions straight across. So I have 8 root 3 over 3 is QR. Okay. Now let's look at PR. PR is the longest leg, and I know that the longest leg equals the short leg, 4 root 3 over 3, times the square root of 3. All right. The square root of 3 times the square root of 3 equals 3. So I have 4 times 3 over 3. That cancels out. And so PR equals 4. And again, you weren't asked to find that. However, I thought it would be a good practice. Okay. Let's look at example 4. Example 4, you have this triangle, and it tells you, what I want you to notice is this, I guess, that there are actually 3 triangles here, 3 60, 30, 60, 90s. You have the small triangle, okay? You have a medium triangle, and that inking not working very well. You have a medium triangle. Okay? And then you have a great big large triangle. All 3 of those triangles are 30, 60, 90 triangles. So we're going to be able to find all of these measures. So first of all, we're going to focus on the small triangle. Okay, and I'm going to try and draw it just the way that it is. I didn't do that very well. Let me try that again. Sorry. Let's try that again. How about that? Maybe not much better, but this is X, this is B, this is C, and this point right here is E. Okay? I'm told that X equals 7 root 3. I need to find little a, and I need to find CE on this triangle. Okay? Well, little a is the hypotenuse. It's directly across from the right angle, and I know the hypotenuse on a 30, 60, 90 is 2 times the short leg. So a just equals 14 root 3. Okay? When I try to find CE, I know that CE is the longest leg of this triangle, so that equals the short leg times the square root of 3. The square root of 3 times the square root of 3 is 3, so I have 7 times 3, or 21. Okay, so CE equals 21. Now I'm going to focus on the bigger triangle, the medium-sized one. Okay, this is my 90 degree. This is still E. If you look, this is E, this is C, this is little leg B or side B. I have A down here, and this side right here is Y. Okay, so I need to find Y and B. Remember that we just found out that CE is 21, and that's actually the short leg of this triangle. Okay, I know that the hypotenuse is 2 times the short leg, so B equals 2 times 21, which is the same thing as 42. Okay, and then I know that Y equals my short leg, 21, times the square root of 3. And that's it. That's example 4. Okay. All right. Example 5 asks you or tells you that the perimeter of an equilateral triangle is 45 centimeters. So let's try and draw an equilateral triangle. Remember what we know about equilateral triangles. I know that all 3 sides are the same and all 3 angles are the same. So really these are all 60 degrees. Okay? If the perimeter is 45, then I know that each side measures 15 centimeters, just because I can take that and divide it by 3, and that'll give me my side length. So there's my side length. Okay. So altitude, I don't know if you guys remember what the altitude is, but if you think about a plane, altitude tells how high a plane is flying. Altitude is the same thing as height. It's the perpendicular from a vertex to the opposite side. So if I were to go from this vertex and drop a perpendicular, I have created a 30, 60, 90 triangle, okay? And that will help me find the altitude. So I'm just going to actually redraw this section of my triangle. I know that this is 15, this is 60, this is 30, and it's a right angle because it's a perpendicular. Thinking about what we know about perpendiculars, what we know about 30, 60, 90s, if the hypotenuse is 15, the short leg is half of that, or 7.5, and then this third leg, or the altitude, remember the longest leg is the short leg, times the square root of 3. So altitude equals 7.5 times root 3. Okay? Example 6, I already graphed this. And this is just the point I want to make. I graphed points A and B, and I note that the distance between these two, and I just counted the grids, is 7, okay? It tells me that this is a 45, 45, 90 with the right angle at point B. So the right angle has to be right here. And if this is a 45, 45, I know that this segment has to be congruent to that segment. So if AB is 7 units long, then BP better be 7 units long. So all you have to do is take the point BP and add 7 units to the Y value. Or you can just count up 7 units. So coordinate P is 4, 8. Okay? All right, so your homework assignment for this lesson is page 369. And it's a little bit different than what was on your notes. So I'm going to slide that in there. Page 369. And you can see what that is. And I'm getting very close to 15 minutes, and that's the longest our video can be. So I'm going to go ahead and sign out. Remember, this is lesson 7.3. I will post 7.2's answers. I'll finish working it out and just snapshot it and post it in my big campus as 7.2 answers. Okay? Good luck.